obtain the mathematical model, right? Do it yourself. Obtain the mathematical model of the mechanical system shown in figure. How many equations you will get? 3 equations, because 3 masses are there, m1, m2, m3. That's why you will get 3 masses. Draw free body diagram, then write the equation. What are the forces acting on it? Displacement in m1 is x1, displacement in m2 is x2, displacement in m3 is x3. The first equation is m1 d square x1 by dt square plus k1 x1 minus x2. Why? Because it is connected between first mass and second mass. That's why x1 minus x2 plus b1 d upon dt of only x1, because another reference is one end is connected to mass 1, another end is connected to reference, equal to 0. No applied force in the first mass. What is second equation? m2 d square x2 upon dt square plus k1 x2 minus x1 plus k3. One end is fixed to m2, another end is reference. That's why k3, another end is fixed. Therefore, k3 x2 only plus b2 d by dt of x2 minus x3. Applied force is there, f of t, therefore equal to f of t. This is second equation. Third mass, m3 d square x3 by dt square plus, we can write b2 d upon dt of x3 minus x2 plus k2 multiply, one end is fixed, therefore k2 x3 equal to 0. No applied force. That's all. 3 equations we got. Now let us find the force. Let us find the force voltage analogy. Force voltage analogy. For that, what we have to write? L1 d square q1 by dt square plus k1 equal to what? For force 1 by c1. 1 by c1 q1 minus q2 plus r1 dq1 by dt equal to 0. This can be written as L1 di1 upon dt plus 1 by c1 integral of I1 minus I2 dt plus dq by dt, dq q1, yes, q1 is I1, R1 I1 equal to 0. Similarly, if you consider the second equation, what you will get? L2 d I2 by dt, directly you will write di2 by dt plus k1 equal to what? 1 by c1 I2 minus I1 dt integral plus k3 1 by c3 integral of I2 dt plus B2 R2 multiplied by I2 minus I3 equal to f of t. Sorry, v of t. V of t. This is second equation. This is first equation. This is second equation. Third equation, L3 di3 upon dt plus time up 1 minute. We'll write the third equation and finish. L3 di3 by dt plus what is 1 by B2 equal to 1 by C2. B2 equal to 1 by C2, sorry, R2. R2 I3 minus I2 plus K2 equal to what? 1 by C2 integral of I3 dt equal to 0. That's all. So now we have to draw the circuit. There are three equations. Here, you have to notice that I2 minus I3. So there is an element between second loop and third loop. If you consider the first equation, first loop and second loop, sometimes 1 and 3 will come. No such problem here. That's why only 3 loops. 3 loops are there. The first loop L1 is there. Current through this is I1. Current through this is I2. Current through this is I3. The first loop L1 is there. L1. C1 is between first loop and second loop. C1. R1 is in the first loop only. So we can draw here R1. That's all. In the second equation, if you consider the second equation, where it is written, directly we wrote L2. L2 is in I2 only. L2. I1 minus I2, C1 already drawn. C3 is in second loop only. C3 is in second loop only. So we can draw here. C3 is in second loop. R2 is between second loop and third loop. R2 is between second loop and third loop. Applied voltage is V of t. That is also in this loop. Therefore, we have to draw here or here. In this loop only, not a common. Therefore, we will draw here. That is V of t. That's all about this V of t. It should be positive. The direction, this should be positive. While writing V of t, this should be positive because in the current direction, it should be positive. Okay. Then third loop, L3 is there. The third loop, L3 is there. R2 is between, already we have drawn, 1 by C3. C3 is there. This is in this loop only. So we can draw here, C3. That's all. This is force, voltage and all. See? C2 is which equation? L3, R2, C3. Only 3 elements only. Mass. This is resistance. This is, that's all. This is capacitance. This is inductance. This is capacitance. This is resistance. Only three elements.